Hi and welcome to Sketching Quadratics Part 4. In this video we're going to talk about how to go from a graph to a function. And this will be the last of a bit of a mini-series. After this we're going to go on and talk briefly about quadratic transformations and general transformation form. But for now, this really wraps up the idea of sketching quadratics, starting with the basic shape and the information you can get from different forms, through to the overall premise, which was last video, drawing a graph from a function, to this video, getting a function from a graph. So if you're getting a function from a graph, here's what I recommend. Start by having a close look at the graph and just highlight all the information you actually know. Now in my two graphs, both my turning points and my x-intercepts are going to be obvious. So I'm going to actually use them once each, just to make sure that they're clear. So in this case, I'm going to use my turning point. We'll go with that. So my turning point is 1, -1. And so when I put that into my turning point form, you remember that y is equal to a x minus h squared plus k, where h is equal to 1, x minus 1 squared, and k is equal to -1, minus 1. Now, if you know the turning point, you have all the information apart from your a. And all you need to do to find a is know one other coordinate. So if you know the turning point and one other coordinate, you can get your function. In any other case, you need at least 3 pieces of information. But if you know the turning point, you technically only need 2. So now let's use the extra piece of information, which is 0, 0 is a coordinate. Now, obviously, generally it is a coordinate, but it's also a coordinate on our function. So I can substitute that in. Y is equal to 0, x is equal to 0, and I get this function. And so that gives me 0 is equal to a -1 squared minus 1. And that's just equal to a minus 1 is equal to 0. And that means that a actually equals 1. And so my final and overall function is y equals x minus 1 squared minus 1. And you'll see I've written a plus there, minus 1. And that's our final function. And this is a really common procedure. Turning point in, substitute other known point to find a. Job done. Let's have a look at a second example. So in this case, I promised that I would use my zeros form. So I'm going to write y, or factored form, is equal to a x minus p x minus q. And so this, I do know my turning point. This also has these zeros. And so if I know those zeros, as in 0 and 4, I can put them in as my p and q. P is equal to 0 and q is equal to 4. Doesn't matter what order I use. So I get y equals a x minus 0, x minus 4. And that actually gives me y equals ax x minus 4. Now we're at that point again where we have all the information apart from a. And so a is the thing that we need to find. And I'm going to use one other coordinate, which in this case I might actually use this coordinate instead of using a turning point. So as long as you know one other coordinate, I can substitute in 1, 6 for x and y to give me 6 is equal to a times 1 minus 4. And that means that 6 is equal to a times -3, which means that a is actually equal to -2. And so I get y is equal to -2 x minus 0 x minus 4. Let me just draw that one again. And that's equal to -2x x minus 4. And there's our function. Now don't mistake, if you do this using a turning point form, it will look different. Your answer will look different to that. but it will be the same answer. It's just in a different form. So if you expanded this answer in a turning point form, you go back to standard form. And note also, if you wanted to go straight into standard form, you could use the fact that you know two intercepts and another coordinate and just substitute three coordinates in. You get a big massive simultaneous equation you can solve from there. That's another option you've got, but realistically you want to avoid that option where possible. So there you have it, going from a graph to a function using our quadratic procedures.